The information in this video comes from thorough research. Please share your thoughts on the video Archimedes in the comments. We'd love to hear what you think. Give me a place to stand, and I will move the earth. Archimedes. Archimedes, the genius of ancient Syracuse. Archimedes of Syracuse, c. 287 BCC, 212 BCE, is considered one of the greatest mathematicians, engineers, physicists, inventors, and astronomers of classical antiquity. His brilliance and creativity revolutionized various fields of science and mathematics, laying foundational principles that are still studied and admired today. This comprehensive text will explore the life, discoveries, inventions, writings, and lasting legacy of this extraordinary thinker. Early life and background. Archimedes was born in the city of Syracuse on the island of Sicily, which at the time was a Greek city-state and an important center of learning and trade. His birth is generally dated to around 287 BCE. Though little is known about his personal life, some ancient sources mention that his father was an astronomer named Phidias. This may have played a role in inspiring Archimedes to explore the natural sciences from an early age. Syracuse was a vibrant cultural hub, influenced by both Greek and local Sicilian traditions. Archimedes likely received a classical Greek education, which would have included instruction in rhetoric, philosophy, mathematics, and possibly music and poetry. He is also believed to have studied in Alexandria, Egypt, where he came into contact with other great minds, such as Conon of Samos and Eratosthenes. These early experiences likely shaped his understanding of geometry, physics, and mechanics. Mathematical contributions. Geometry and the method of exhaustion. Archimedes made groundbreaking advances in geometry, particularly in the study of areas and volumes. One of his most important methods was the method of exhaustion, a precursor to integral calculus. Using this method, he was able to approximate the value of pi, and determine the areas of curved surfaces and the volumes of solids, such as spheres and cylinders. For example, in his work on the sphere and cylinder, Archimedes demonstrated that the volume and surface area of a sphere are 2/3 that of the cylinder that encloses it. This was a major discovery, and Archimedes was reportedly so proud of it that he requested a sphere and cylinder be engraved on his tombstone. The measurement of a circle. Archimedes was the first mathematician to accurately estimate the value of pi. He showed that pi must lie between 3 and 1/7, approximately 3.142857, and 3 and 1071, approximately 3.140845, a remarkable achievement given the tools of his time. He arrived at this result by inscribing and circumscribing polygons around a circle and calculating their perimeters. The quadrature of the parabola. Another masterpiece of Archimedes is the quadrature of the parabola, in which he demonstrated that the area under a parabola can be calculated by summing an infinite geometric series. This again shows a deep understanding of infinitesimals and anticipates the development of calculus nearly 2 millennia later. Combinatorics and arithmetic. Although better known for geometry and mechanics, Archimedes also made contributions to number theory and combinatorics. In his work, The Sand Reckoner, he attempted to calculate the number of grains of sand that could fit in the universe. To do this, he developed a system of large numbers that extended beyond the Greek numeral system of the time. Inventions and mechanical devices. Archimedes was not only a theoretical genius, but also a practical inventor. Many of his mechanical inventions demonstrate his profound understanding of physics, especially the principles of levers, buoyancy, and fluid dynamics. The Archimedean screw. Perhaps the most famous invention attributed to Archimedes is the Archimedean screw, a device used to raise water from a lower level to a higher one. It consists of a helical screw enclosed in a cylinder, which, when turned, scoops water upward. This invention is still used in modern irrigation systems and wastewater treatment plants. The lever principle. Archimedes is famously quoted as saying, "Give me a place to stand, and I will move the earth." This statement reflects his discovery of the principle of the lever. He studied the relationship between force, distance, and weight. laying the foundation for classical mechanics. His insights allowed for the development of pulleys, winches, and catapults, war machines, and defenses. During the Roman siege of Syracuse, 214 to 212 BC, Archimedes reportedly designed several war machines to defend the city. These included giant cranes to capsize ships, catapults that could fire heavy stones, and mirrors that allegedly focused sunlight to burn enemy ships, though this last claim is debated by historians. His devices were so effective that they delayed the Roman conquest for years. Archimedes and hydrostatics. The principle of buoyancy. Archimedes made a fundamental discovery in the field of fluid mechanics, known today as Archimedes' principle. This states that a body submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. This principle is still taught in physics classes worldwide and is essential in shipbuilding and fluid dynamics. According to legend, Archimedes discovered this principle while taking a bath. Upon realizing the solution, he is said to have run naked through the streets of Syracuse shouting, "Eureka! I found it!" Whether or not the story is true, it captures the brilliance and excitement of scientific discovery. Applications of buoyancy. Using this principle, Archimedes was able to determine whether a crown was made of pure gold or a mixture of metals without damaging it, an early example of non-destructive testing. He did this by comparing the weight of the crown in air with its apparent weight in water. Astronomy and cosmology. Although Archimedes is less known for his work in astronomy, he made several important observations. He constructed devices that could predict the positions of celestial bodies and eclipses. Some ancient sources suggest he built a mechanical planetarium that mimicked the movements of the sun, moon, and planets. In the Sand Reckoner, Archimedes also attempted to estimate the size of the universe. He argued against the limited Greek view of the cosmos and proposed a system in which the Earth revolved around a much larger universe, showing a surprisingly modern understanding of astronomical scale. Death and the Roman conquest. The end of Archimedes' life came during the Roman conquest of Syracuse in 212 BCE, led by the general Marcus Claudius Marcellus. Despite orders to spare Archimedes, he was killed by a Roman soldier. Accounts vary, but it is generally believed that he was absorbed in a mathematical problem when he was approached, and he allegedly told the soldier, "Do not disturb my circles." Marcellus was reportedly angry at the killing, recognizing the immense value of Archimedes' intellect. The loss of Archimedes was a significant blow to the ancient scientific world. Writings and lost works. Many of Archimedes' writings survived through Greek and Arabic translations, though others were lost. His surviving works include On the Sphere and Cylinder, On the Measurement of a Circle, On Floating Bodies, The Sand Reckoner, The Quadrature of the Parabola, The Method of Mechanical Theorems. A significant discovery occurred in the 20th century with the recovery of the Archimedes palimpsest, a manuscript that contained several previously unknown works, including the method. This revealed even more about Archimedes' advanced mathematical thinking, including his early use of infinitesimals and his geometric intuition. Legacy and influence. Archimedes' influence on science and mathematics has endured for over 2 millennia. His discoveries were studied by later scholars in the Islamic Golden Age, Renaissance Europe, and the modern era. His mechanical insights were foundational for later developments in physics and engineering. Influence on modern science. Figures such as Galileo Galilei, Johannes Kepler, Isaac Newton, and Carl Friedrich Gauss all acknowledged the importance of Archimedes' work. Newton is known to have said that Archimedes was one of the few minds he truly admired. Archimedes' principle is still taught in physics. His methods form the basis for modern calculus and mechanics, and his inventive spirit continues to inspire engineers and scientists. Archimedes in popular culture. Archimedes has been referenced in literature, art, and modern media. He appears as a symbol of genius and curiosity. Statues and busts of Archimedes exist in many scientific institutions, and his Eureka moment remains a powerful image of discovery. Archimedes was a towering figure in ancient science, combining deep theoretical insight with practical genius. His contributions to mathematics, physics, engineering, and astronomy were centuries ahead of his time. He explored the secrets of geometry, discovered the laws of buoyancy, invented useful machines, and even speculated on the size of the universe. His legacy endures not only in textbooks and laboratories, but also in the human spirit of inquiry, creativity, and wonder. Archimedes remains a symbol of the power of thought, a reminder that with imagination and logic, even the mysteries of the cosmos can be unraveled. I set sail not with certainty, but with faith that beyond the endless horizon lay a world waiting to be revealed. The ocean was vast, but my will was vaster. Christopher Columbus. If you have any experiences related to this topic, be sure to share them with us. Until the next episode, be mindful of the energies around you.